don't know where everybody else went. Because I haven't seen it. So here on the right side, other example. What does it mean for number 5?
Find 0. If find y equals 0. Oh, then there's 2 zeros and this one's gonna have 3 zeros.
Okay, maybe. It could have 3 zeros.
Well,
This one could have 2 zeros. Okay?
well,
What's the minimum amount?
2 zeros? None.
It could have none.
Yeah.
What's something else you know about this?
It'll have 2. That one will have 2.
Do you know the y-intercept? If x is 0, what is y?
X is 0, y is negative. Yeah.
So we know here it's -6. So if you know that, you know it's coming up because this is positive.
True.
We know it has to have 2 zeros. We can factor it. We can plug it in our calculator. We get something like a negative, I forgot. I have to look at it. X plus 3 and x minus 2. Is that correct?
Oh,
Factor?
Yep.
So we got a positive 2 and a negative 3.
that
and
one
that's coming up.
has to be the calculator.
Okay? On this test, test 6B, when it says approximate, then I'm going to come into my calculator.
I think I did it in my calculator.
Plug it in.
So I zoomed out.
So you, because ultimately you know the y-intercept is -8. We should know it's positive, so it's coming up. Somewhere I think I have.
It goes like June. It could hit 3 times.
It could hit 3 times. Does it have to?
No, it only could hit it once.
Could only hit it once.
But it's
Every-
gotta hit it.
Every cubic function must hit at least
This,
once.
yeah, this one's only
Okay, so if I go in, I need to see my equation. Y equals, I'm clearing all that, I've got an x cubed minus 20x squared plus 14x minus 8.
We cannot see it.
Okay.
It has to be zooming or zoom out.
So, if we hit graph, I'm zoom graph, or tree right now. It doesn't show up. So if we zoom out, you have to hit enter again. I kind of see it.
I see it.
I see it. Zoom out.
Zoom
You have to, okay, you need to be at the 0. So go like around 0, 0. Yeah, and hit enter. So to zoom out from that point.
Oh.
You have to hit enter twice.
Oh.
Okay?
That's so tiny.
So now if you want to zoom and figure out. So this graph, being a cubic function, we know it's going to hit at -8. That is our y-intercept, yes? If x is 0, what is y? Okay? But then we see from when we graph it, the cubic function is doing something like this. Okay? Not exactly like that because it's way far over here to the right. Okay? But it only has 1 0. So I probably am going to go way over here. And that's not going to tell me a great spot where it is. But I could zoom in at that point.
Or you could just calculate.
Or we can hit second
Bam.
calculate,
2, 0. Yeah.
find a 0.
Second calculator.
Left bound.
Oh, but I want to go way over here.
Second calculator.
Well, I mean, it doesn't really matter. Oh, you're too.
I'm too far. Because I need y to be negative. Okay, there we go.
What did you hit? Second calculator.
And then it says left bound, and I'm hitting the arrows.
Which one?
You're trying to find the 0,
Oh,
right? Because that's what it's asking for.
0.
And now from there, I'm going to hit the arrow over, and I'm going to get farther over here. I don't see my cursor.
Outside?
Okay? Do I need to use my logic brain to figure out where it is?
Yes.
The x has to be positive. has to be negative. Because if I go too much farther, all of a sudden I'm positive and I jumped above. Okay? So I'm going to go back to the left and I'm going to hit enter. And it even drew a little line there. If it's fancy, it'll do that. And it says right bound, so I'm going to go to the right and I'm going to hit enter.
How in the world did you do that? I don't like calculating. Oh.
Then it says guess. You can literally just hit enter again.
Wait.
And it will give you,
Okay, I stopped here. Okay. I don't know.
okay,
Out.
no, that's just going to zoom it out, make it even
Oh,
bigger.
zoom in.
You want to zoom in, where do you want to zoom in at? Where's your cursor?
I don't know.
You got to find it. It's the thing. Look to where your numbers
How
are.
can I find it?
Okay, when you turned it on, it was there. X is 15, Y is negative 20. Where do you think positive 15, negative 20 is? Down. So I'm going to go up.
Oh, you can go up.
Arrow. Give a direction. Okay. I'm going to go up till X is 0. And I'm going to scoot over until I get close to that line. And I'm going to hit enter.
Okay.
And it's not going to show anything but that line.
Okay. And then
I'm still going to hit second calculate zeros.
okay.
Left bound. The cursor's never going to be able to.
Where's that dot?
Say that again.
Where's that dot? The trace. Where's the dot? The bound. The stop.
I'm not going to say it
So how can you do it now?
because I can look at these numbers and know where it is.
Oh, where is this?
Okay, so right now I'm somewhere at 18 and Y is negative 259. And if I go to the right, my Y is getting bigger. Really, it's moving up towards here, right?
How did you know how big?
I don't.
I did it, but it said no answer.
So left bound, you have to be to the left of this, so Y has to be negative.
Yeah.
Because you have to know that that's coming up from the bottom.
Yeah.
And you hit enter. Right bound. So now the Y has to be on the right side.
I mean, what I mean is, how did you know you didn't touch the line or you didn't right?
Because it's not showing up in there.
How can you know how much?
Because I'm looking at the numbers.
Yeah, but I don't know how big to look at.
You're looking at your Y value. Okay? Can Y be negative and be on the right bound? To the right side of where it crosses the zero. You're trying to find this dot right
Yeah.
now. So to the left bound, it's going to be negative. To the right bound, it's going to be positive. So if Y is negative at 1,
To the right of the positive.
so if I keep going to the right, do I get to the right of it?
Wait, that doesn't make sense. This line is positive. I mean, no, maybe
Below the x-axis is negative. Above the x-axis is positive. The Y value.
yeah, I know.
So I want to know when is the Y going to be positive? Is it positive yet? Should I go farther to the right?
That this is a straight line.
It's a curve.
Oh, that's a curve.
Cubes are, all of this is curved.
Oh, okay.
Okay? So should I keep going to the right?
Yeah.
Oh, I went above it. I'm already at 23.
And then
Hit enter. Yes. We don't even care. We don't have to even move.
okay.
Okay? And then it blinks right there.
Okay.
So what is your zero?
No, it's like a
19.
it's pretty deep.
All right. Does everybody, can you find that x value? What is the x value of this answer?
19.3.
Okay, I do like a few more decimals when they're giving lots of decimals.
How many you want?
19 point. I've got 19.29594 at least 2. I think I wrote that on a few homeworks I gave back. I like more decimals. The book usually gives me 5 or more.
Oh.
When you give me 1, it doesn't seem quite enough.
So it's 19.9,
Maybe
5, 9, 4,
okay.
X. No, Y.
Yes. That's, they don't care about the y. The y has to be there.
Okay. Thank you.
What other questions did you have on this? Number 7, find the distance. Or express the distance. So let's look at number 7. Express the distance from point 1, 4. So we have a 1, 4 to a point x, y on the graph of y equals. Okay, so first question is, what does it mean with distance? Do you know the distance formula?
Oh,
From a point to another point?
I know the slope.
Well,
That's the square root of
the square root of.
x2 minus x1 plus y2.
Excellent. X2 minus x1 squared plus y2 minus y1 squared. So do we have an x and a y? Do we have two x and y's? Oh, wait, it says as a function of x. So, and then where in the world does this thing come in? Y equals x to the 4th. Here. If you have an x and you have a y, and we need to plug things in. What are we plugging in?
X minus 1.
Okay, but then it says as a function of x. So what in the world does this y equal? X to the 4th.
Ha! It's kind of that.
So here we have an x, comma, x to the 4th. That's the only thing you need this for. It's the only thing you need that for.
Oh, that's not.
Okay? So now you plug into an expression. So what's x minus x? From this point to that point.
X minus X. X. Oh, y.
You've got 2 points. This is number 7 on your 6B test.
X minus 1.
So do you see an x and you see an x? From this point to that point. So is it really this x minus 1? You're just plugging it in. Squared plus. What's y minus y?
X to the 4th.
But what is my y? X to the 4th minus 4. Squared. Believe it or not, that's all they want.
That's it?
That's all they want.
Nope.
We don't need to make it more specific. Just write it down.
All they want. I mean, I'm sure people have foiled and tried to do, but you can't take square roots of anything, so it just becomes a big long mess.
Oh, okay.
And you really can't combine stuff in the middle. This is simplified. That's all they want.
On the test, I didn't foil it. It's okay. Even it can be a foil.
I'm saying, please leave it like this.
I will.
Please.
Is it the same as if you take off the squares? Like what that's the same?
Meaning, is this really x minus 1 plus x to the 4th minus 4? There's this little thing. But there's a triangle, and it's a 3, 4, 5 triangle. What do you know about this 3, 4, 5 triangle?
It's a
3 plus 4 is not equal to 5.
So if I take the square root of both sides, okay, I'm taking the square root of both sides. What's the square root of 5 squared?
5.
So what does 5 equal to? And we cannot just take the square root of one piece plus another piece.
Yeah, I didn't know if you followed that same rule.
You didn't follow that rule growing up?
No, I mean, like, I didn't know if that's not
Oh, okay. Yes, that matters because there's a sign there, that is what makes it different. There's a plus. If that was a multiplication sign, that would be different. Okay? Or a division sign, that would be different. But if there's an addition or subtraction, you cannot pull it apart. Okay?
Okay.
What other number? Which number? 8. What does 8 say? Oh, it's a verify. That you need the back of your plate for, right? So what happens on things like number 8? Number 8 that says, show that one. So you can square minus sine. This is a verify. Going back. I-F-Y. There we go. Verify. What does it mean to verify?
To make both the same.
To make them equal to each other. Whoa. So, you know we want to talk about these quizzes, and we will, I promise. But can we rewrite? What was the first rule of verifying? So, question is, can we rewrite this?
Yeah,
What is that?
it is sine squared x.
Does everybody see that that's a Pythagorean identity? Yes. So we have this times what?
It is 1 over sine squared x. Right. That minus sine squared x.
Okay? So now I have a sine squared times 1 over sine squared.
It's going to cancel out and become 1.
This is going to become 1. You see that because this is sine over 1.
That.
And now we have a 1 minus sine squared x.
Sine squared x. What?
Oh, I forgot about these.
Verifications are good. Okay. What else?
Can you turn the domain
On 11, the domain and the range.
Wow, so 8 is that easy? It's just like,
Rewrite it. A verification.
that's
Yes.
what it is.
Yeah, when I say show that,
Can you like write what the whole out in brackets? That works very well.
if you can ask me, you may it's going to be the same type of problem. Number 8 will be the same type of problem. So when you see all that trick stuff, you're saying, hey, I need to verify that this side equals that side. And stop there. You know, don't for all those that's for both sides of the equation are defined. We don't really care. Okay? So, here we go. If f of x equals e to the x and g to the x equals natural log x, what is the domain and range of these two things? I might ask before I go to A and B, what's the domain of e to the x?
All real numbers.
What can I plug in? All real numbers. Okay? So I might make two separate What about the range? What are we getting out?
Well, we know it can't be negative.
I don't know.
Wait.
So maybe, great thing I see on tests are little T charts.
I think all of them.
You think all real numbers. Well, what does this look like?
Because if you put negative.
If x is 0, what is y?
0.
E raised to the 0.
It's
One.
1. Now, you know e is just a number. It's like pi.
Yeah.
Yeah.
2.7. So put in a 2. Or 3, whatever. So if x is 1, what is y?
E.
E. 2.7, whatever. What happens if it's negative 1?
1 over 27. It's 27.
1 divided by 2.7 or 1 over e. Okay? 2.72, an infinite number of decimals after that, like pi. Okay? But it's just a
Yeah.
natural number. Okay, so what happens if I go to 2?
I knew it. Yeah, they can't be negative. I said that, and I wasn't sure, but I know now.
Okay? So does this graph really look like this?
Yes.
Or the other direction? No, it's the other direction. What? I didn't do that.
Cannot be negative.
Here, we're at 0, 1, but if it's at 1, it's up. Down, it's this way. Sorry. That's the graph. Sorry. But can they be negative? So what's the range?
It's bigger than 0.
Can it equal 0?
No.
No.
Never.
What about the domain of natural log x? Can we put in anything?
Yes.
Did you try it in your calculator? Natural log -2.
Oh yeah, you can't put it.
Oh!
It's
Because you
in there.
automatically just say all real numbers.
But no.
But what happens when you try to plug in
Oh, I
negative
forgot.
numbers?
You can put in any positive number.
Okay, so can you plug in 0?
No.
Oh, see, then I'm actually going to use my calculator.
Well, you cannot put 0.
X must be greater than 0.
Wait, why cannot put 0?
Why can't you say all real numbers such that
That's
it's
what,
greater than 0?
that's what it
Oh, okay.
That's what it says.
Because.
I was just taking time.
Oh, okay.
And like this one should be y is a set of all real numbers such that. I just didn't, I'm just being a little lazy.
Is it because of
Well, what do you know about logs?
I don't remember.
You have to remember logs. Okay.
Uh,
Log.
maybe we should do log every day.
I wish we had time to do log every day.
2, 6.
Stop. Anyways,
Yeah, I'm stop.
what's log base 10 of 10?
1.
How do you know that?
Because 10 is 10 to the first equals 10.
We had that question, and I said.
Oh.
Okay, so here we have log base E, and if I put a number here, no. If I put a number here, what's that going to equal?
1.
What raised to E is going to equal 0?
1.
0.
No.
Wait.
Nothing. It's impossible.
Wait. E to raise what is 0?
E raised to the first power is E.
It's
Yeah.
impossible.
E raised to the 0 power is
1.
1.
So that does not exist. Nothing.
Not exist. That's why you cannot plug 0 in to get anything.
Oh, this is
Because
fascinating.
nothing raised to a power will ever give you 0.
Thanks.
Okay? If we're
Okay.
remembering the details of log, that's why it has to be greater
Oh.
than 0.
Thank you. Now I remember.
So now what is the range?
This graph.
So if I were to graph and look at, so I know I can't put in 0, could I put in a fraction? And I'm probably going to use my calculator. If x is, well, even if x is 1, what is y?
2.7. No. Hold on. I'm so
I mean, plug it in. Natural log 1.
0.
0. Yes. What's natural log 2? Now we got a decimal.
0.69.
0.69. What about 3?
Good job.
23 or just 3?
No, if x equals 3.
1.09.
1.09. So we know
Give me
this.
another one.
Give me, what about
bigger.
0.5?
Negative 69.
Oh, whoa.
Negative
whoa.
0.69.
This is, it starts going on.
It's just so long.
Okay, so what does the graph look like? So my x can't be 0, but at decimals, it's where? Negative, sorry.
I don't understand why we get negative.
Because it's a fraction, and 1/2 can be written as 1 raised, can be written as 2 raised to the negative 1.
Oh, I'm so sorry.
Okay? So that's going to be a fraction, whatever's on the bottom is a negative exponent.
Okay.
Okay?
Okay.
So at a half, we're negative. At 1, we're 0. At 2, we're 6.69. At 3 here. Is this graph going to look like this?
So
It almost was.
as long as it. So is that range?
I don't know. What is the range?
Why is the real number?
Wait, range is
Yeah, because we've already decided the domain.
Range is your
y.
output.
Why is real number?
Yeah, it looks like it's gonna go forever.
And
So?
y will be
So, or y equals all real numbers.
y will be bigger than 10. No, it's bigger than 0. No.
The input, the x's, you can only plug in positive x's, but you can get out negative, and you can plug in as many as you want to see if you get something opposite. So now, what is the domain of f of g?
Let's find out. F of g. So f of g will be
I'm going to erase some of this on the bottom, if that's okay.
gonna be e to the I natural log x.
So now, how does doing this help me to find the domain of f of g?
It'll have the same, no, the restricted version of the domain on it.
It will have-
And then, well, it'll have the restricted version of both.
I'm going to try it, just to make sure.
What does that mean?
What does
Like,
what
you have
mean?
to do the one with the most limits.
Is one of these domain restrictive? Does it have
It'll have
something we
whichever one
can't
you-
do? So what does f of g look like?
So it's gonna be, the domain's gonna be x equals all real numbers, such that it's over 0.
So this is really e raised
Oh,
to the
sorry.
what?
Ln x.
Natural log x.
Yeah, that's exactly.
Can we double check ourselves by graphing?
So how can I
So what's going to happen?
the domain?
Wait,
Is there something here?
How does it get there?
Okay, that's the question. This
Oh,
over here to the left was not the question. We just,
no,
it's
I mean,
easy.
I know, I'm just saying, like, so
F
f of g,
of g of x means this.
I mean,
F of g means I'm plugging in g
okay.
into f. Okay? So natural log x, I'm plugging in. So E, my domain inputs, was there anything I couldn't plug in? But here, was there something that restricted it?
You cannot plug
Yes.
So are there some x's that I can't plug in?
E.
So I would say x is a set of all real numbers such that.
So it's basically just putting the
Putting them together. But I'm still going to look at both. What about letter B? When it was g of f, which was really g of f of x. I'm going to write them out. Ln e to the x. So e of x, I can put anything I want in, right? But when I put anything in, Meaning if I plug in x is -1, what happens, what's going to happen with what I get out? It's going to have an error, right? So this is the case where I can only plug in still greater than 0 because this is the only piece that will show up in this, those outputs.
That makes sense.
So this also will be,
So you also use it as restricted. Oh wait,
yes,
that's still domain.
yeah. They don't ask about the range.
NDR. Oh, okay.
They don't ask about the range.
But if they do, is it also restricted?
It will be restricted to one of those, yes.
Okay. Can we do all? Yes. Just in case tomorrow.
Probably tomorrow won't even be this hard.
Oh.
That's sometimes why I hate this test versus the other one.
That's
That
the
is not
problem.
gonna be-
So
I'd
I
rather
need to
this
start that
be harder.
Wait,
And that's
so,
general-
Although sometimes it does trip me up.
so the test has everything.
The test will be almost exactly like this. I will say, number 5 is extremely a lot easier than this number 5. This number 11 is a lot easier on the other one.
Oh, question. Is
Yes.
number
Just a second. Taylor, yes. A.
okay? Hey, that's my question. Oh, I have another. 4 essays. Okay. So this one, just curious. So this one will be this, right?
This should be.
And this will be this. Right?
I would have to work it out to determine it.
So you cannot just tell.
I don't. I always write them out and I always look at them.
Okay.
Every time. All right, what other? Number 12. Use the definition of a derivative. The quiz yesterday, you did not have to find use the definition. It did not ask you to. Okay, but when it says use the definition, you use the definition.
Yeah, I messed up.
But the good thing about this,
So dy over dx is the same as f
over delta x equals dx of y equals, we had a whole list that one day. They all mean the same thing. And more people got tripped up on that one than they did on the one before it, which was I thought was a harder one because we hadn't even talked really about what happens when there's a coefficient in front of it. We didn't, but we've done it before.
What's the answer?
What is the answer to number 12? What's the shortcut really quick? How do you know the answer to number 12?
I know it's
16.
16. Yes.
And that's it. But how do we use the definition?
F of x plus h minus f of x. Oh, you're gonna do that. Plus 7 minus 16x plus 7.
Now, what I am going to say is do not leave out the most important piece. Whether it's use h or whether you use delta x, do not forget this.
Okay.
Do not forget that. We're not going to,
Right, the formula not big,
I would love to write the formula.
not big,
Do what?
not big.
You have to have it. Always.
On the plate.
No. Definition of a derivative. Always. Write it down right now. Write it 12 times between now and tomorrow. Okay? It is f prime of x equals the limit as delta x approaches 0 of f of x plus delta x
Minus f of x over delta x.
We're not done.
Can we see this? I have a question.
So, do you want me to finish working this?
I think we already go through every question. This, I put in the calculator. Square root of 2 is 1 point something.
Where did you get to?
Square root.
But where's
Oh, you want me to close it?
Yeah, actually have the whole graph.
Oh,
So it shouldn't stop.
okay, thank you.
Why is this
What did you do? That one. Right? So on the bottom we have 5. I put 5 on the bottom. What about on the top? Oh, right? So when you plug in the infinity, that's a big deal. If you forgot the limit on how much I would have 3-1. So what is it?
Oh.
Divided by 5. What is it? Divided by 5.
Is it up here? Is it your cartilage?
Don't touch it.
No. It's too
Follow. Did you want me to do this?
No, I sent my mom a picture, and she said I better be a magnet, and then I said dot dot dot. She never responded. She wasn't scared at all.
She didn't.
Taylor, are you ready?
Do we have the
That's a good story.
I mean, it should do something. Not a straight, it's not a straight line. It doesn't have a positive slope. Or a same slope. Will you?
Thank you so much.
That's why I said you have to put it down.
No, I need that.
Thank you.
Where did Justin go?
I'm coming. In the next hour.
Or come at lunch. Somewhere I'm recording and I need to stop.